analyze this graph. And we're going to start by identifying the multiplicity of each root. I'll look on the x-axis and identify all of the x-intercepts. For this particular problem, when x equals -2, we do have a real root, but the multiplicity is even. In fact, it has a multiplicity of 2 because it bounces off. When x is equal to 0, we do have a real root. Again, it slightly bounces off. It has an even multiplicity. When x is 1, it cuts through. So we have an odd multiplicity, a multiplicity of 1 because it cuts straight through. And when x is equal to 3, the function bounces off the x-axis, so we have an even multiplicity of 2. Even multiplicity, odd, even, odd, even. Multiplicity 2, 2, 1, 2. Now describing increasing and decreasing intervals. We always look from left to right and we describe them in terms of x values. So first I'm going to verbalize it. Decreasing, increasing, decreasing, increasing, decreasing, increasing, and decreasing. I am going to have to do some approximations here. So it's decreasing from coming from the far left hand side, or negative infinity for x values, all the way to where x is equal to -2. Remember, at -2 it's not decreasing, it's neutral at -2. I'm approximating here. It's going to increase from -2 to -1.25. Again, we do this in terms of x values. From -1.25 to 0, it is going down or decreasing. From 0 to 0.75, it's approximation on my part. Both in terms of x values, it is increasing. And then it's going to decrease from this 0.75, and it continues to decrease until approximately 2.25. It will increase here from when x is 2.25 up to 3, before finally decreasing from +3 to infinity. Now, a lot of students ask me, why is this positive infinity since it's going down? Remember, in terms of x values, it's moving to the right as it goes down. The key is in terms of x values. Same with here. They see a negative infinity and it doesn't make sense. In terms of x values, it's coming from the far left. Option D and E ask us to evaluate where the function is positive and negative. Remember, anything above the x-axis is positive, anything below the x-axis is negative, and anything on the x-axis is neutral, because y is equal to 0 on the x-axis and 0 is neutral. It's neither positive or negative. I'm going to help here by actually darkening in where it is positive. Everything here is positive, but note on again, your x-intercepts aren't positive, they're neutral. So I would write the intervals where the function is positive as these 3 intervals describe where the function is positive. Negative infinity in terms of x's to -2, -2 to 0, and 0 to 1. Anything that has a little dashed line is going to represent where the function is negative. Again, keep in mind that at 3 it's neither positive or negative, it is neutral. So here is negative, and here's negative. Again, most students want to make this a negative, common mistake. They want to make this into a negative infinity symbol. In terms of x values, it's moving to the right. That's why this is positive. And the last 4, options F through I, are going to ask us to identify absolute and local maximums and minimums. So for this function, I can see there will be no absolute maximum and there will be no absolute minimum, and that's because this function continues to move down as it goes to the right, and the function continues to go up as it moves to the left. So there's never one point that we can identify as being the highest or lowest. There is no absolute maximum, there is no absolute minimum. Now there are local maximums. So this point, -2, 0, it is a minimum, a low point. This is a local maximum, -1.25, and maybe about 10. This is a local minimum, 0, 0. This is a local maximum, again I'm approximating, 0.7 7, 5, and maybe 4, 5. And then we're going to come down here. This is also a local minimum, which is 2 and negative 20. This is a local maximum, 3, 0.